Welcome back, Python enthusiasts. Today, we're diving deep into a fundamental concept of Python programming, namespaces. Have you ever wondered how Python keeps track of all those names in your code without getting them mixed up? Well, that's where namespaces come into play. But what exactly is a namespace? A namespace in Python is essentially a system to make sure that all the names in a program are unique and can be used without conflict. It's like a dictionary where the key is the name and the value is whatever the name refers to, like a variable, function, class, module, or another namespace. Namespaces help organize and manage the elements of a Python program, preventing naming conflicts and providing a structured way to access variables, functions, and other objects. To understand namespaces, we need to delve into how Python identifies and manages names. When you run a Python script or execute code in a Python interpreter, Python creates a namespace for that code. A namespace can be thought of as a mapping of names to objects. There are different namespaces at different levels of the Python program. 1. Local namespace. Every function call creates its own local namespace. It contains the names that are defined inside the function and exists only during the execution of that function. Local namespaces are destroyed once the function call completes. When a function is called, Python creates a local namespace for that function. Any names defined within the function are stored in this local namespace. For example, in this example, local_variable is a name defined within the my_function, so it belongs to the local namespace of that function. 2. Global namespace. This namespace contains names defined at the level of the current module. It exists throughout the module and is shared among all the functions and classes defined within that module. The global namespace contains names defined at the top level of the module. These names are accessible from any part of the module. For example, here, global_variable is defined outside any function, making it part of the global namespace of the module. 3. Built-in namespace. This namespace contains names of all built-in functions, exceptions, and attributes. It is automatically loaded when Python starts up and is always available. The built-in namespace contains names of all built-in functions, exceptions, and attributes. These names are automatically available in any Python program without the need for any import statements. For example, in this code, print and len are built-in functions accessed from the built-in namespace. Now, let's understand the role and importance of namespaces in Python. 1. Name resolution. When Python encounters a name, it searches for that name in a specific order, first in the local namespace, then in the global namespace, and finally in the built-in namespace. This order is known as the LEGB rule: local, enclosing, global, built-in. If the name is not found in any of these namespaces, Python raises a name error. 2. Preventing name conflicts. Namespaces help prevent naming conflicts by providing a way to encapsulate names within specific scopes. For example, you can have a variable named count in both a local and a global namespace without conflicts because they exist in different scopes. 3. Encapsulation and modularity. Namespaces enable encapsulation and modularity by allowing you to organize your code into modules, classes, and functions. Each module has its own global namespace, and each class or function call creates its own local namespace. This helps in keeping code organized and maintainable. 4. Code readability and maintenance. Properly utilizing namespaces can improve the readability and maintainability of your code by clearly defining the scope of names. This makes it easier to understand where variables, functions, and classes are defined and used. Namespace lookup. When you reference a name in Python, the interpreter follows the LEGB or local, enclosing, global, built-in rule to resolve the name. Let's understand one by one. Local. If the name is defined as a local variable within the current function, Python uses that value. In closing, if the name is not found locally, Python looks in the enclosing functions, if any. This is relevant for nested functions. Global. If the name is not found in the local or enclosing namespaces, Python looks in the global namespace of the module. Built-in. If the name is not found in any of the above namespaces, Python finally looks in the built-in namespace. If the name is not found in any of these namespaces, Python raises a name error. Managing namespaces. In Python, you can manipulate namespaces using various techniques. 1. Namespace modification. You can add, modify, or delete names within a namespace using assignment statements or del statements. 2. Namespace access. You can access names within a namespace using dot notation. For example, module_name.variable_name accesses a variable_name defined in module_name. 3. Namespace aliasing. You can create aliases for namespaces using the import statement. For example, import module_name as alias_name creates an alias_name for the namespace of module_name. 4. Explicit namespace access. You can access names from specific namespaces using the from module_name import variable_name statement, directly imports variable_name from module_name into the current namespace. Best practices. When working with namespaces in Python, it's essential to follow some best practices to write clean and maintainable code. 1. Avoid polluting global namespace. Minimize the number of names defined in the global namespace to prevent clutter and potential naming conflicts. 2. Use descriptive names. Choose meaningful and descriptive names for variables, functions, classes, and modules to improve code readability and maintainability. 3. Encapsulate logic. Encapsulate related functionality into separate modules, classes, or functions to keep namespaces clean and organized. 4. Avoid shadowing built-in names. Avoid defining names that shadow built-in functions or names to prevent confusion and potential errors. 5. Use module-level imports. Prefer importing modules at the module level rather than within functions to make dependencies explicit and avoid namespace pollution. By understanding namespaces and following best practices, you can write more organized, maintainable, and scalable Python code. Namespaces play a crucial role in managing the scope and visibility of names within a Python program, facilitating code reuse, encapsulation, and modularity. So, the next time you're writing Python code and wondering how it all fits together, remember the power of namespaces. They're like the invisible architects behind the scenes, keeping everything in order and making sure your code runs smoothly. That's all for today, folks. Thanks for joining me on this journey through the world of Python namespaces. Stay curious, keep coding, and I'll see you in the next video. Happy coding!